Alright guys, so now we are going to study the section 5.3, logarithm. A logarithm is a way to rewrite an exponential equation. And you're going to see it's not very complicated, but if you don't know what you're supposed to know, it will be impossible for you to solve the problem. So there's two things that you need to remember. The first thing is, if you have, and let me write that in blue, it will be better, I think. There we go. So if you have an exponential equation a to the y equal x, well, you should remember that means that y is going to be equal to log base a of x. So you had the base a to the y equal x. Now y is going to be equal to log base a of x. Two things to remember. First of all, x has to be greater than 0. So x has to be greater than 0. That is very important. Okay? All right. So, second of all, what you need to remember is the logarithm properties. And these logarithm properties are six properties, okay, that you are going to use at some point in time. And if you are paying attention, you will see that it is very easy. It is just manipulating the log as you were manipulating anything before this session. So let's try to look at the trying to expand the example number 3. I know you have that on the side, but let me try to show you what we could do. Also, it's going to be the same thing, but I want to give you some explanation. So we're having log base c. I tend to, when I'm writing and I'm manipulating my log, I tend to exaggerate the length of my g in order for me to have the base way down below, because I don't want to be confused between my base and any coefficient that I could find just right here as a multiplication of my parentheses. Okay, so the first thing I want to do is put my base, and then I'm going to have a cubed times c to the 4th divided by b to the 5th times d to the 6th. So what do you see right here? It's very simple. What do you see? Is a fraction, and so that is exactly look like as log base c of a numerator divided by a denominator. And you know from the property number 4, for the property number 4, that you know that is going to be equal to the log base c of x minus the log base c of y. So now, if you have x as a cube c to the 4th, and if you have y equal b to the 5th times d to the 6th, well, the log of base c of x is going to be the log of a cube times c to the 4th. The log of base c of y equal log of b to the 5th times d to the 6th. Are we done yet? No, we're not done yet. Why? Because when you look at your log base a, log base c of a cube times c to the 4th, that remind you the log base c of the multiplication of a multiplied by b. And you know that is going to be equal to the log base c of a plus the log base c of b. So in your case, you are going to have is log base c of a cube times c to the 4th, and that is going to be equal to the log base c of a cube times the log of c to the 4th, plus, c to the 4th. And now, I guess now you understand where I'm going, because now this log base c of a cube, and let me just rewrite this base c right here, okay. Now, what do you see is you can see this exponent by using the property number 5 is going to come in the front. Same thing for this one. And we can do exactly the same thing for the log of y, which is log base, and I forgot to write the base, so let me write the base right here, base c of b to the 5th, b to the 4th. I'm going to have log base c of y is going to be equal to log base c of b to the 5th plus the log base c of a to the 6th. And my d, it's a d, d to the 6th. This is a d. And using my rule, my property number 5, I'm going to have to do this. Okay, then I just need to reunite everything, and you will have at the end of the day the answer returned just right here. Okay, so I'll let you do the example number 4. Let me see if I have some space on the next page. Yes, I have some space on the next page, and actually it is already be done a little bit. So let me try to do what we have right there. So what do we have? Let me check. We're having minus 25 log base c of a plus 36 minus 41. Okay, so what I want to do is trying to focus on the minus 25 log base c of a. That is going to be equal to log base c of a to the negative 25. Okay? Then I could have, and remember, a to the negative n equal 1 over a to the n. So that could be also be equal to log base c of 1 over a to the 25. Okay? Now, if I look at the other one is 36 log base c of b, which is log base c of 36 to the b. And if I take the last one, minus 41 log base c of d, log base c of d, it is equal to log of d to the negative 41, and using this rule of exponent right there, I'm going to have log base c of 1 of d to the 41. Now I'm going to reunite these three terms, so I'm going to have now is a log base c of 1 to the a to the 25 plus log base c of what? Of 36 to the b plus log base c of 1 over d to the 41. Now I'm using my rule of exponent. Log base plus log base equal the multiplication of the two log, and so I'm getting a log base c. I got the same base in my two log, which is very important. 1 over a to the 25 times 36 to the b, which is and I finish my equation, a log plus log base c of 1 over d to the 41. Now I'm going to multiply to have the same denominator, and I'm getting to have the same denominator, and I'm getting a log of 36 to the b divided by a to the 25, log base c, of course, plus log of 1 over d to the 41. And again, I'm going to multiply my two logs, and I end up to have a log 36 to the b over a to the 25 times d to the 41. Why do I have that? Because when you multiply this fraction right here, let me take another color. When you multiply this fraction right there with this fraction right here, we got the top multiplied by the top, 36 over to the b multiplied by 1 give me 36, and then a to the 25, oops, I didn't take the a right here, So let me rewrite that in a better way. Here we go. And now right there I'm supposed to have a to the 25. So a to the 25 multiplied by d to the 41 give me a to the 25 multiplied by d to the 41. All right, guys. So now I'm going to let you try to work out your different example. Let me help you a few seconds. First of all, when I look at 2 cubed and 8, well, what I could do if I was in a section 5.2 is 2 cube equal 2 cube. So basically, I end up to have a 2 equal 2 or a 3 equal 3, 2 equal 2, or 3 equal 3. Now, if I want to use the base, I'm going to have log base 3 of 8 equal 2. All right? Remember, 2 is the base, so, oh, I made a mistake. See, I made a mistake, completely made a mistake, because I was going too fast, so don't go too fast, don't do like me, and let me do that again. The base is 2, because the base is 2, I'm going to write log base 2 of 8 equal log base 2 of 3 of 8 equal 3, okay? Now, if I want to do the same thing right here, that's pretty simple. First and foremost, I'm going to write that 1 over 2, it's 2 to the negative 1. And so 1 over 2 to the minus 4, it's going to be 2 to the negative 1 to the minus 4, which is going to be 2 to the plus 4. And now what do we have? We're having 2 to the plus 4 equals 16. That means log base 2 of 16 equal 2. Now, if I want to transform log base 5 to the 25 equal 2, that means I'm going to have 5 to the 2 equal 25. And we know that 5 squared equal 25. Same thing for this one. 3 to the 4 equal 81. And yes, 3 to the 4 equal 81. All right. So I'll let you try to solve the example number 2, 3, and 4 by yourself. And let's try to work out the example number 5. Well, the example number 5 is evaluate log 12. When you have log 12, the question is, what is the base? Okay, well, when you have nothing, the base is supposed to be 10. All right, so right here, basically what the question is, evaluate the value of log base 10 of 12. Okay, so I'll let you use your calculator and you will find that very easily. So please, these are the property that you need to use. So you have the property, you have the example. Please try to apply this property to the example. Take your time, it's very easy. When I'm doing the property number 3, let's try to do the property number 3 for you. When you're looking at the property number 3, what do we have is pretty simple. We're having a log base 2 of 3 times log times x. And so that means log base 3 of base 2 of 3 plus log base 2 of x, applying directly the product rule property. Okay, so use all these rules, or you use all these property number 4, property number 5, and property number 6 to rewrite the log. Now, if I have log base 10 of 10 to the x, I know it's going to be x log base 10 of 10, and log base 10 of 10 is 1, so that is going to be equal to x. Okay, and why log base 10 of 10 is 1? Because if I'm correct, you should have the property right here, property number 2. If you look at the property number 2, you can see that log base a of a equal 1. Thank you very much. I think we are done regarding all of this property. And I will probably add few examples to this video in the set of video that you have to look at for before to come to class, and I will try to do some of the example number 18 and 20 probably. Thank you very much, and talk to you in class.